and today we are going to discuss about Bernoulli's principle and hydraulic bands, and their order codes are HD150.07 and HD150. In this video, we are going to discuss about its application, components and principle of working. So this is the Bernoulli's principle demonstrator, in which we have first one is Bernoulli's principle apparatus and the second one is base module for experiments in fluid mechanics. So firstly, we have to supply the water to Bernoulli's principle apparatus by using the hydraulic bands. So in the bottom one, we have base module for experiments in fluid mechanics. We have firstly indicator to turn on and off button and connected to the power supply. And this is the control valve which is directly connected to the submersible motor present in the floor tank. And this is the floor tank in which we have to fill the water approximately 3/4 of full capacity. And these are the measuring tanks in which we have to measure the drain valve water from Bernoulli's principle demonstrator, and this is the scale in liters. And this is the last one is drain valve directly connected to the measuring tank, through which we can drain out the water remaining in the floor tank. So this is the Bernoulli's principle demonstrator, in which we have first one is inlet valve, which is directly connected to the hose connection, through which the water supplied through the Venturi tube. In Venturi tube, we have 6 different positions for measurement of water gauge pressure. There are 6 tube water pressure gauge measurements, and last one is pitot tube for measuring the water pressure. This is vent valve for removing air bubbles from the lines, and this vent valve is for managing the pressure inside the pitot tube. And this is the discharge pipe through which the water is drained to the measuring tank, and this is outlet valve, and this probe is used for making different pressure at different position inside the Venturi tube. So let's come to the experiment. So our experiment is to verify the Bernoulli's equation experimentally. So now we have already filled the floor tank approximately 3/4 of total capacity and directly connected to the hose connection through Bernoulli's principle demonstrator. So now we have to turn on the hydraulic bands through which the water gets pumped inside the Bernoulli's principle apparatus. So as you can see, the water is directly coming through inlet valve inside the Venturi tube. Now we have to open the vent valve for releasing air bubbles inside the pressure gauge tube. Now we have to turn off this vent valve and release the pressure through this valve. So now, as you can see, in the first tube we have the reading approximately 220 millimeters, and in second one is 225 millimeters. In the third one we have 195 mm. In fourth one we have 170 mm. In fifth we have 210 mm, and in last one we have 230 mm. So you have to take observation according to the table from H1 to H6, in which H1 to H6 are the 6 pressure gauge tubes, and R1 and R2 are the measuring tank capacity initial and final. So as you can see, we have measuring capacity right now is 10 liters. So now in first observation table, you have to take the readings according to the time by using this stopwatch. So firstly you have to take the readings of 6 tubes from H1 to H6, R1 and R2, which is measuring tank capacity initial and final, and this is time which is displayed in stopwatch. Now in the second observation table from H1 to H6, we have to take the readings using pitot tube by releasing pressure inside the Venturi tube. So there are 6 measuring positions inside the Venturi tube. This is the probe. We have to adjust at each position, and you can see the reading in the pitot tube changes. So in first position we have approximately 120, which is basically 220 mm. So this scale starts from 0, and according to this scale, this is from 100 mm. So 120 plus 100 is 220 mm. Now the reading is increased. The reading is slightly decreased, approximately 115, which is basically 215, and in last it goes below 115. So now we have to make the calculation according to the taken observation in this table. So first we have to calculate the R, which is rise in water inside the measuring tank, and R2 and R1 are final and initial water level inside the measuring tank, and Q is discharge through test section, A is area, and V1 to V6 are velocity of 6 pressure gauge tubes. After this, we have to calculate the energy from E1 to E6 of each pressure gauge tube. And lastly, QTH is theoretical discharge, and CD is discharge coefficient for Venturi meter, which is calculated by Q upon QTH. Now finally, we have to plot the graph between pressure head and distance, velocity head and distance, and total energy head and distance by using these calculations.